Hello, hello. My name is Muslim. Can you guys hear me, by the way? Just like there's something random in the chat. Sweet. Okay, great. My name is Tarek. I'm also one of the project managers for Disruptive Tech, except I work on blockchain stuff, same as Bhavan. Welcome to, I believe, what is DT's final session for tonight, which is pretty sweet. It's been a long day, and other project managers have done quite a bit. What I'm going to be focusing on today is creating a blockchain auction system. Okay, sweet, great. All right, as stated before, I'm one of the PMs here at QMind on Disruptive Tech, working on blockchain, and we're going to be going over a blockchain auction system that's built on smart contracts. So let's get started. A couple things to get started. Okay, that's weird. Anyways, basic Python knowledge. Some basic blockchain knowledge. That second part or that first part might actually get scrapped because I've been having some real issues setting up the Python environment to interact with the blockchain stuff for some reason. I think a new version came out today and it's just been messing with me. So we might have to scrap the interacting with smart contracts and just focusing on writing for today, which is all right because it's a pretty long smart contract. Anyways, yeah, basic blockchain knowledge. Matt and Bhavan talked pretty extensively over them earlier. So I'm hoping you guys paid a little bit of attention, even if you didn't. Remix and Solidity is kind enough to abstract most of it for us. Anyways, Ganache, which is just a local Ethereum testnet, and then Web3.py, which is used for interacting with smart contracts. All right, sweet. So how would a blockchain-based smart contract work? So basically, there's a couple of basic rules we need to follow. If you know how an auction works, it's basically just everyone's just making bets on a certain item where everyone tries to outbid each other. One person places more than another person, and so on and so forth. And it's just that's just basic auction. So sellers must be able to create an auction. Buyers must be able to make a bid, and if their bid's the highest bid that's available, then they should be next in line to receive the item. And basically, at the end of the auction, whenever it ends, the seller must be able to withdraw the funds. And the seller must also be able to cancel the auction and return the funds to the buyers should the seller decide to cancel the auction for whatever reason. Maybe he doesn't get as much money as he wants, whatever the case may be. All right, let's move to Remix and start building our smart contract. Actually, before that, I just want to talk a little bit because all this tech is cool and it's all pretty neat, but it's kind of useless if there's no real reason to. Hold up, sorry. All right, that wasn't nice anymore. Okay. It's kind of useless if there's no real good reason for it, right? So let's just talk about some issues with the traditional centralized auctions and some benefits of these blockchain-based auctions. So with a central auction, you kind of have this lack of transparency due to the fact that it's central. A common tactic used in auctions nowadays is that some people just have a fall person where essentially they just keep bidding higher and higher to drive the price up of a certain auction. And they have an agreement at the end where even if that person wins and, the fake buyer makes the highest bid, they'll just resell it at a later date because they want to drive up prices. And that's just a big issue in terms of just, corruption. On a blockchain-based system, since everything's open, no one can really do that because everything would kind of get caught right away. And transactions could be made super easily because, it's hosted on the blockchain network. So I guess for me, that's kind of one of the big reasons to use blockchain to solve something like this compared to, just going on eBay and posting something randomly or just any other blockchain space. All right, let's move on to the smart contract development. So, let's just go over the interface really quickly. We have the contract auction. Bhavan earlier went over some of the syntax stuff. Solidity is kind of like JavaScript, kind of like Python. It's typed pretty similarly. Of course, in the first line, you have to state your version. Actually, did I set up the right? Yeah, okay, that's incorrect. You want to make sure that it's or the same or higher. I'm just going to do the same because, I don't know, it might not work with higher stuff. 0.4.8. Sweet. Great. Oh yeah, you probably want to learn how to go clone the project. Okay. So once you have the home folder, same as earlier, I should probably drop the link. I'll go grab it. This will take 2 seconds. All right. I just threw it in the chat. Anyways, so you just grab that link. You go to the main kind of like homepage here. You go to GitHub. You paste in the link I just sent in the chat. Click OK. It'll create a new file somewhere. There's gonna be a bunch of other template stuff that's already here. But yeah, you just open GitHub. You know, it's my name. Keep my workshop auction.soul. It'll take you right here if you want to follow along. Which you don't have to, but it's probably a better learning opportunity if you do. Anyways, now let's finally get to the interface. So we have the contract auction, and we're gonna have a couple of functions associated with it, right? We're going to have something to get the highest bid, to place a bid, to cancel the auction. I guess it's all the way down. And basically just to log everything, right? We want to plan a couple storage variables. We want the address of the owner because we only really want the owner to have access to certain rights regarding the auction. For example, canceling it. It wouldn't be a very good auction system if like one of the buyers could just like send a request to cancel the auction. We want to get the start and end block. I'll explain why in a bit because like the way you kind of get time intervals in Solidity and Ethereum in general, it's kind of like wonky. You want to get the IPFS hash. I'll go into further what that is later. This Boolean canceled. This will basically tell us if they choose to cancel it, in which case we'll just like kind of kill the auction. The highest binding bid. I'll actually explain this. Yeah, I'll explain this in a bit. In many popular auction platforms, users kind of bid to the maximum they're willing to pay by not binding them for that full amount, but rather they just give to the highest bid plus like a certain amount. So for example, let's say you bid like $450 and the bid increment to like place in another bet is $10, then you only need you can bid $500, but you only need to bid $440 in order to like win the auction or to be the next in line for winning. So in this case, even though the current highest bid is $430, the highest binding bid would be like $440. So that's kind of what's the highest binding bid is. Other than that, a lot of these are kind of self-explanatory in terms of canceled and, the highest bidder, you're just getting their address, who they are and stuff like that. If the owner's withdrawn, he's taking the money out and things like that. So yeah, let's just go into the constructor then. Okay, so we're checking a couple of things here. We're refusing to create auctions with invalid start and end times, right? So we're making sure that if an auction started with like a time that, or like the start time is after the end time, and again, I'll explain later, but the way we measure time in Solidity and Ethereum is by looking at the blocks. Then we essentially just like don't allow the auction to get created because then we'll run into some annoying errors. We also reject auctions with like an empty owner parameter because if someone can just create a random auction and there's no owner and then people put money into it, then it's just kind of lost. So we want to make sure we can reject that. Okay, so placing a bid. We should do a little bit of planning for placing the bid. And I'll teach you guys about a little bit of neat little things you should do. So basically, we know that there are only certain cases where it should be possible to place a new bid, It shouldn't be allowed when an auction or before an auction starts, after it ends, or if it's canceled. And we should also know that it would be considered like a hazard if the owner was also allowed to place bids, like that scam I was telling you about earlier. We need to make sure that place bid cancels these situations if they do happen. So it does sound like quite a bit of preconditions. So we use these what are called function modifiers. So we can see what they do at the bottom here. Yeah, they'll make sure only the owner can send it, or not only the owner. It's only after the start or before the end, only not canceled, so on and so forth. It's not just the owner of the address. Yeah, that would be hard to do, actually. Yeah, I don't think that would be possible in this case. You could run, because like anyone can just kind of create their own account. So yeah, that's an interesting insight into how to do it. Perhaps there are better blockchain contracts that would look into how to do that. Anyway, we try to err on the side of kind of many small modifiers so that each are like as minimal as possible, so we can have more reusable code. And like try to think of how if we had like the opposite approach and we just kind of threw everything into here. For example, we might have decided to like like make like an only running modifier or something like that prevents certain actions unless the auction was already running. You think, okay, cool, sweet. You place this bunch of like booleans in place bid and cancel auction, but like I don't know, it would make sense if you cancel the auction before it starts instead of doing all these things. Anyways, let's finally think about how place bid should actually work. So you might think to yourself, users should be able to place Ether into this function, and depending on how much they spent, they would either become the highest bidder, and they'll cost like the highest binding bid to increase as well, right? And the first implementation you might think of is that in terms of like when you want to refund someone's Ethereum, it's like, okay, if they're the highest bidder and they get outbid by someone else, you might think to yourself, oh, we should just like resend their money back to them, right? Or when someone places a bid greater than the highest binding bid, but less than the highest bidder's maximum bid, we should just refund it, If it's like too little to be considered to move the highest binding bid, that seems rather intuitive, but it's actually not the way you're supposed to do things, and it's kind of a bad practice. There was something called the Dao hack that happened a while ago, where what was it, like $150 million worth of Ethereum was actually stolen, and we know it's after that it's best to stick to a more withdrawal pattern. So this helps us avoid re-entrance bugs that could cause unexpected behavior. So we should only send Ethereum to a user when they explicitly request it, and we should try to avoid doing as much of anything else like in the function. For example, like let's say a user sent like a bid to a contract with like basically like a malicious function in there that would like just use a bunch of gas fees provided to it, right? Then this user would never be outbid because whenever someone else like tries to make a bid, the network would kind of send the Ethereum back to that malicious function, and then the function would run out of gas, preventing the new bid from being recorded. So they could pay like the smallest amount, and then everyone else just keeps losing because like they keep after paying like these huge like gas fees. So place bid basically at the end of the day should only accept payments of Ethereum and then recalculate some of the contract's variables like highest bidder, funds by bidder, and highest binding bid. If your users outbid, then their Ethereum remains locked up in the contract for the time being. This is fine because we can set it so that they can like withdraw their own things manually for when the auction ends. So with all that being said, let's finally get start to coding. So we want to reject payments of 0 Ethereum. We want to grab the value of the message and just check if it's 0. Then we just want to throw it. All right, it's pretty simple. Here, the comments kind of explain what you need to do. You just calculate the new user's total bid based on the current amount they sent, plus whatever has been sent in that transaction. So the new bid, and then funds by bidder. Plus the message value. And so further ahead, if the user isn't willing to overbid the highest binding bid, there's nothing to do except revert the transaction basically. Like don't let them put new money in if they aren't like putting enough to overbid whoever has the highest. There we go. And then finally, you just want to create an unsigned integer for the highest bid. Basically, we know if this is created, then we know the highest bid is now equal to the new bid, basically. Sweet. Okay, neat. And then we have a couple things in here as well. This is basically to check if the user overbid, but not the highest bid. We just want to increase the highest binding bid and leave the highest bidder alone. So essentially here, we just grab the minimum of the new bid and whatever the increment is, and the highest bid. Whoops. Yeah, I think that's it. Sweet. And then here, if the message sender is already the highest bidder, they must simply wait to raise their maximum bid, in which case we shouldn't increase the highest binding bid. If the user is not the highest bidder, then it's overpaid, but we send them back. Oh, okay. Then we just want to make sure we set that's a new bid. Sweet. All right. So we're handling a bunch of cases here. I'll talk about them in a bit. So, if the user has sent an insufficient amount, we throw it. If a user has sent an amount that's higher than the highest binding bid, but not higher than the highest bid, then we increase the highest binding bid, and that's it, because they haven't really made the highest bid. And if a user sends an amount that's higher than the highest bid, they become they become next in line, and they become the highest bidder. Saying bid so much is starting to lose sense. The current highest bidder wishes to raise their maximum bid, in which case we accept their Ethereum, increment their funds, and do nothing with our storage variables. So, this is all cool, but let's think about withdrawing funds after the auction as well. So when the auction is over, whether it's canceled or not, users should be able to withdraw Ethereum that they used to place their bids. And withdrawals should only be permitted after an auction has successfully ended. So the time period is ended, or the owner decided to cancel it. Unfortunately, we'll need a new function modifier for this, since the conditions are logically ORed together. So it's one or the other. And technically, since this precondition is used once, we could simply hard code it into the function. So that's the modifier at the bottom here. Only ended or canceled. Yeah, boom, there it is. So, but there's quite a bunch of cases we have to handle here too in terms of design. The owner should be able to withdraw an amount of Ethereum equal to the highest binding bid, and the highest bidder should be able to withdraw any Ethereum they must have sent in excess of it. So the maximum bid minus the highest binding bid, because why would you pay extra? And any other users should be able to withdraw all the Ethereum they sent over the course of the the bidding war. So let's look at the withdraw function. Sweet. So, just notice that we finally make use of our owner has withdrawn storage variable so that we can correctly calculate how much to send to the highest bidder. There are other ways to accomplish this, like storing the highest bid as a storage variable, but for our purposes, it doesn't really matter too much. So, let's just work on filling in this code. Okay. Need to, so if it's canceled, the withdrawal account is the sender. So whoever sends a message to, withdraw is then the withdrawal account. And then we want to return them the amount that's basically, the amount they sent through. The account, right? Okay. Well, otherwise, the auction was finished without being canceled, in which case the owner also has to be able to withdraw their money, right? So they get to be able to withdraw the highest bidder, or the account basically is the highest bidder. And the amount, I didn't put an equal sign. And the amount is then the highest binding bid. Right? So, whoever made the highest, the most contribution. And we want to, the owner of the drum. So that's true. Here, if the message sender, okay, yeah, sweet. So if the owner, you're supposed to do all these things. If you're the highest bidder, then you need that amount like fully withdrawn from you, and you shouldn't be able to have access to it again. Otherwise, people would just make bids and then take their money back at the end after it was like done. And I don't think that'd be a very functional auction. We just take the funds by bidder, so you don't get access to these funds anymore. And the withdrawal amount is basically equal to your fund subtracted by the highest binding bid. So that way you don't have to overpay for anything. There we go. Sweet. And so anyone who participated, they just get to take their own money out. So, it's just them. Whoops. Sender. And let's see what's in the fund by bidder. Okay, sweet. Yeah. So that's basically the withdrawal function and how it works. So, if you notice, there's a kind of a pattern that's starting to emerge where we're kind of doing a couple things. We're checking our preconditions. We're doing some like optimistic accounting. So, we're doing our accounting assuming like the transaction will like succeed and it doesn't just like fail. And then we send Ethereum and we kind of throw if the send fails, and then we log the event and then return. So canceling the auction, let's focus on that now. Okay, our canceling function is actually like really simple. You can kind of just set the canceled variable to true, log an event, and then return. And we've already handled the cases of everyone withdrawing their funds. So we've been able to reuse a lot of our functions here. A lot of these modifiers. So, that's kind of like the benefit of making your code reusable. You get to use it in like multiple spots, which I guess is kind of how it works. So, yeah, that's actually pretty much it in terms of how it works out. Yeah, we have the function modifiers here. You get to withdraw the amounts of rules. Played it there. Canceling the auction is handled. We kind of brushed over this, but this is really simple. It just takes like the min between two variables. I'm surprised Solidity didn't actually have a default thing for it. What's the error here? Okay. This is weird. I'll think about it later. Oh, did I explain how time is used? Yeah, basically, how time, like, there's no way to actually tell time, using a timestamp. So the way it's handled in Solidity is basically you look at the block times, and a new block is created every 15 seconds or so, and we can basically set that to check the time. So when a new block is created, that's a new amount of time. And so that's how the timer is basically created, where the creator of the auction will input an amount of time, whether it be seconds or minutes or however long the auction will take place. And we'll basically take that, the amount of time there is, convert it to seconds, divide by 15, and then add that to the number of blocks. And that's pretty much it. New big. Is that something I missed? Making a new bid? I guess I didn't talk too much about placing a bid. Or I don't know. I think I did. I don't know. David, tell me if I messed up. I'll take care of it. Anyways, yeah, that's pretty much it. We have eBay. An error. Oh, I did? Oh, new big. Yeah, that's totally right. Sweet. Thanks for catching that for me. Okay, it's something so weird here. Okay. Oh, I didn't equal sign. Yeah, that fixes it. Oh my god. All right, yeah. eBay and 100 and what? Oh, there's another one here. What did I do? Another missing equal sign. Wait. In 193 lines of code. Boom. Unlike other platforms and a lot of other smart contract development, the reason why Solidity is actually pretty popular It's not only used on Ethereum, it's used on like a couple other networks as well. I forget the other ones, but I know it's used on, I think, at least like 3. But like, writing Solidity contracts generally involves writing very little code. And, the neat thing about it is you don't need to be another one. What is it? Whatever. I'll come back to it later. But you don't need to be an expert in blockchain in order to, understand Solidity or, write in it, which is pretty cool because it abstracts most of the complex things away from you. So you don't need to worry about cryptography. You don't need to worry about, all these different things. Security, gas costs, and readability are all really important considerations. And, until like there are better analysis tools in terms of running and testing these functions and like how secure it is, how much the gas costs will be to run these functions. Really, it's up to like programmers to make sure that we're doing a good job because, it can be like pretty catastrophic if we create a bug in these contracts and then people end up losing real money, which is why it's really important to test really thoroughly. Finally caught the error. It's just the missing P. And yeah, that's pretty much it. I'd show you guys how to do the front end, but I've been yeah. That's pretty I don't know. I guess it's an error of like coding live. You make those like stupid mistakes, or I guess it's coding all the time though, huh? But yeah, unfortunately, I can't. I'd love to show you guys how to interact with it, but I can't. Like I haven't been able to get the Python libraries to work. I've been working on it since like this morning, which is really unfortunate because it was like the next half of the presentation. So yeah, I'm here to take any questions you guys may have about the contract, or if you guys want to work through it and then ask me questions as you go as well. That would also actually be pretty cool. So yeah, that's about it for me. Or you can check out the other. I believe they're doing how to go about ML projects in the other room on A2 and A3. Oh, okay. If message center is already the highest bidder. Thank you for catching up, Joshua. I really appreciate it. Users something reasons. Well, the highest bidder in this case is the sender. And yeah, basically this is changing the highest bidder now. Because after the new highest bid was created, and we just want to take them in from the new bid and the highest bid plus the bid increment. Yeah, sweet. All right, hold up. Oh my God, what is it this time? Message of sender there. Oh, expected semicolon up here. That's weird. Yeah, that didn't freak out here. I don't know. Oh my God. Another one. Sweet. There we are. Okay, great. Oh, that's embarrassing. All right. I'm going to look through this one more time to make sure I didn't miss anything. Okay. Yeah, returns the highest bidder. You get to place a bid. Yeah. I think this might be an error to do with the. Oh, I think it's because I could just do a event. And that works, right? Yeah. Or no? Okay, weird. This was not showing up earlier. Yeah. Okay. I'm not quite exactly sure. Is it saving? Okay, wait. I'll just read it. Oh, it's probably because it called the wrong thing. Yeah. Okay. Yeah, it's like stupid typos. And this one, same deal. Oh wait, I don't know what I was thinking here. Anyways, yeah, anyone who participated but did not want to win the auction should be allowed to withdraw the amount. We want to get the amount here. The funds by bidder, and then the withdrawal amount. Sweet. No? Account. Same error. There we go. Error-free code. Great. At least I hope it's error-free. Logic error is still a thing. Anyways, yeah, that's it for me. Feel free to point out more of my mistakes, or run through it yourselves. If you have any questions, I left it as a template. When we do the hackathon tomorrow, which I guess we'll discuss then as well. It'll be like a similar type of deal where it'll be like skeleton code, and you guys get to fill in the parts. I guess like the reason why we're doing that is because Solidity, as of now, like we're not expecting you guys to have a full understanding of it the same way you do with your own programming languages that you use like all the time. So we just want to make it easier for you by allowing you to use the skeleton code to your advantage. So yeah, it'll be a similar deal with like lots of comments and then like just lines you can write in terms to see how it works, and hopefully by then it won't be that much of an issue. So yeah, that's actually it for me. Really appreciate you guys listening in. Yeah, sweet. Feel free to throw any questions in the bottom. Hey, Matt.
Hey, Mustafa, how's it going?
David's asking a question. If you have time, could you go over the variable highest binding bid again? Yes. Okay. Yeah, I understand. Because like when I was setting up two, it was like it was kind of confusing. So, all right. I'll run through the example one more time. Like if you're at an auction and you're bidding like $5, right? And that's like the highest bid for like an item right now. And there's another variable called a bid increment, right? And that's like basically so you can stop people from just being like, oh, I'm gonna bid $5.01, because then people are just gonna keep bidding like the extra cent instead of going by like the increment. So like let's say we set the increment to like $1, right? And the highest bid is kind of $5, and the increment is 1. So you decide, all right, sweet, I'm gonna pay $7 to do this amount, but you only really need to pay 6, right? So you only need to do whatever the highest bid is plus like the increments in order to become the next person in line for winning, right? So you only need to pay the $5 amount, that's the highest bid at the moment, plus the $1 increment in order to become the winner. So that's like the highest binding bid is like the one extra increment above whatever the highest is right now. Let me know if that sufficiently answered your question. If it didn't, I'm happy to kind of talk about it some more. Sorry if I cut you off, Matt. All right, Andrew says it's okay. I'm trusting Andrew to be an indicator. Oh wait. So for the block in the place bid function, it says if users overbid. When is it the case the highest binding bid is? Oh, that's just when the code's running, and like as it's going, the highest we increase the highest bid first, and then like after the highest binding. So that's just while the code's running. That's not necessarily a thing that's happening at any moment. But like while the code's like being run, that'll be the case. Yep, sweet. Okay, Matt, you can go ahead finally.
No, well, I just wanted to say thanks, Mustafa, and Bhavan and the rest of the speakers, really. If people keep questions coming, if you have them. I just wanted to say a big thanks to all the speakers today. And that pretty much brings us to the end of the disruptive tech specific onboarding and workshops. We covered a ton today. Like we tried to introduce you guys to like 2 brand new complicated technologies, their own new tech stacks and everything in like 3 hours each, or total, I guess. So, we just hope to expose you to a little bit and get you used to sort of the terms and the concepts. And we don't expect you to go out and start building crazy applications tomorrow. We're spending the next, as I said in the beginning, we're going to spend another couple weeks further onboarding, getting you guys working sort of like one-on-one with your PMs and with the rest of your team to do like a bit of a warm-up project and really try to ease you into it. But yeah, we have like solutions or completed templates from what's on the repo already. So that's the repo that we've been talking about. That's like our specific folder. And so I'm just going to push the solutions right now. Sick. So yeah, I just added solutions that you can go and check. I recommend still like trying to work through the skeleton code, like the templates, and try to figure it out on your own based on what's in the question. If you can't, maybe try Googling something. If not, then take a look at the solutions and feel free to reach out to the PM that designed it. But yeah, thank you so much for paying attention. And the next speaker, he's going to be awesome. Cooper in the main stage. He's a cool guy, so it's definitely worth checking out. But that's all from us, and we will see you guys tomorrow. Thanks.